In the third question of test 2, we were asked to find out the Newton forward difference interpolation algorithm. Now, in the Newton forward difference interpolation, we need to find an estimate at the point of interpolation. Starting off with the algorithm, we need to keep in mind that the most important part of this algorithm is to construct a forward difference table. Now, moving on to the algorithm, first step would be start. Then we need to read n, that is number of arguments. Then we need to iterate I equals to 0 to n by minus 1. And then we will read xi and yi. Now we will end the for loop. In step 4, we will construct the forward difference table. In this, we will create two nested for loop. First loop would be iterating j equals to 1 to n minus 1, and second loop would be iterating I equals to 0 to n minus 1 minus j. Then we will assign yij equals to yi plus 1 j plus j minus 1 minus yi j minus 1. We will end both for loop. Now we will print the table. For that, we will be iterating two nested for loop again. Here we can see that we need to iterate I equals to 0 to n minus 1 and j equals to 0 to n minus 1 minus j. Print yij, then end for loop, next line end for I loop. Step 6 is reading a point of interpolation. Then we need to assign n equals to x1 minus x0, that is the step length. Then we need to assign u, that is a minus step length minus upon h. Then we need to assign sum equals to y0 and p equals to 1.0. P is nothing but the product here. Then in step 10, we need to iterate j equals to 1 to n minus 1. The product will be product into u minus j into I, u into j minus 1 upon j. Then the sum will be sum plus product into y naught j. Then we need to end the for loop again and display a. That would be the point of interpolation, and the sum, that would be the value of interpolation that was the that to be found. And we will stop here. The third question comes to an end.